Hello Legacy Sabers, Marsh here. So today we're going to talk about imaginary and complex numbers. You want your notes, pen or pencil, and then also a calculator to do some simple multiplication. So, once upon a time, a man sat down to solve a quadratic equation. Looked like x squared plus 10 equals 0. Now, you guys probably would know how to solve this, right? You'd subtract 10. You get x squared equals negative 10, and you would square root both sides because x squared and square root cancel each other out. But you can't take the square root of a negative 10. And he freezes and he goes, oh, what do I do? There's no solution to this answer. What am I supposed to do? Well, this man was named Descartes. And he decided that since his calculator did not understand the negative square roots, he just made a new number system. And thus the imaginary numbers were born. Now, we're asking, what are imaginary numbers? Well, imaginary number is the letter I. That's what you're going to designate it as. And what I is just the square root of negative 1. So basically, this just the square root of the negative. So on that note, I squared is also negative 1, because if I multiply the square root of negative 1 times the square root of negative 1, the square roots cancel and I just get negative 1 underneath. Keep that in mind as we keep going here today. So how are you going to use I to rewrite a square root? Well, what you're going to do first is you're going to have to kind of break down a square root. So I have the square root of negative 25. And notice, guys, that I'm first going to make it so I have the square root of negative 1 times the square root of 25. That's a legal move. When you multiply two radicals, technically you can multiply what's known as the radicand together. That's the numbers on the inside, the radicand. So, I know the square root of negative 1 is just I. And then the square root of 25 is 5, right? So my final answer would be 5i. So the square root of negative 25 is just 5i. So basically that negative, all it does is makes an I on the outside. So same thing here. I can break this into the square root of negative 1 times the square root of 6. This is just I. Square root of 6 does not break down. So it would be I times the square root of 6. Not too bad. Now let's try this one. Square root of negative 40. Well, very first thing, I need to pull out the square root of negative 1, because there's a negative there. But now 40 breaks down, doesn't it? Long ago, remember when you were breaking down square roots, you found the biggest perfect square that can go in, and then you divided it and stuff like that, right? So the biggest square root that I know goes in there is 4, and 4 times 10 is 40, right? So I got square root of negative 1 times the square root of 4 times the square root of 10. So basically all I'm doing is just separating this out. Square root of negative 1 is just I. Square root of 4 is 2. And then I have the square root of 10 yet. So my final answer, if I write it nice, would be 2i square root of 10. Just so it looks kind of cleaner and a lot nicer if you want to say it that way. Now, let's try one when there's a number sitting outside. All it is that 5 is just going to kind of come along for the ride. So I'm going to have 5 times, and then I have square root of negative 1. Now, I got to break down the square root of 48. 4 can go in there. However, I don't think that's the biggest number, biggest perfect square. 4, 9 doesn't. 16. 16 times 3. That'll give us 48. So I'll have square root of 16 times the square root of 3. So 5 square root of negative 1 is just I. Square root of 16 is just 4. And then I have square root of 3 left over. So if I multiply my outside here, it looks like I got 20i square root of 3. Let's look at the last one of this area here. Now notice, guys, there is a fraction under a radical. That is a big no-no. Big no-no. So what you want to do is you want to break that into two separate little radicals. So I'm going to have square root of negative 10 over the square root of 3. Now, something to keep in mind, you're not allowed to have a radical on the bottom either. That's also a big no-no. So we're going to rationalize the denominator, aka multiply the top and the bottom by the square root of 3. So on the top here, I'm going to get square root of negative 30. Bottom, I'm going to get technically what would be the square root of 9, but square root of 9 is just 3. Now notice, guys, I have a negative still on the top. So it looks like I got an I to come out. 30 does not break down over 3. Now you cannot simplify this at all. Do not, because this 30 is inside the radical. The 3 is not. Thus, they are not able to be simplified any further. Now, how do you simplify complex numbers? So basically something with part real, part imaginary. And we're going to look at a couple of different examples first. So one where you just need to distribute I into a expression. So I'm going to multiply I in, just like you would multiply the number 3. So I times 3, all that is just 3I. And then I times I is I squared. Now, if you remember at the beginning of this video, we learned or talked about how I squared was equal to negative 1, right? Because if I is just the square root of negative 1 and I square that, that's going to cancel out my squared and my square root, and I'm going to just get negative 1. So what I'm going to need to do is simplify this I squared here. So that's going to be 3I plus what would be now negative 1. And something to do, it is considered customary that you keep the real first, then the imaginary piece. So always write it so normal number plus, or depending on it, could be a minus, part with an I. Okay? Keep that in mind. This piece right here looks like we're adding. So all you need to do is add the real, add the imaginary, and simplify if required. So I got 3 plus 4, that's going to give me 7. Then 2I plus negative 6I, that is negative 4I. And I swear if that is it for that problem. Those are super simple. Adding and subtracting are pretty simple when you're doing with i's. Subtracting, however, please make sure you distribute that negative, or be careful when you're thinking through it. Okay, keep that in mind. Multiplying or FOIL isn't as bad either. So let's multiply everybody by everybody, kind of like you normally would when we multiplied earlier in the year. So I got 3I times 4, that is 12I. 3I times a negative 5I, that is negative 15I squared. 6 times 4, that is 24. And 6 times negative 5I is negative 30I. Now, what I'm going to do, I'm going to simplify my pieces with my i's. So that would give me a negative 18i. Plus I have the rest of everything. Now, we did talk about how I squared was negative 1. So what I need to do is simplify this inside term right here, this piece right there. So this would be negative 18i minus 15, but I squared is just negative 1 in disguise. So I gotta write it like that. Negative 18i. Notice negative 15 times a negative 1 is a positive 15. Add those two numbers together. I'm going to get 39 minus 18i for a final answer. Little bit of a work, takes a little bit, but it's actually not too bad. Just be careful with that I squared business. Make sure you always remember that's a negative 1. Now, as we're talking a little further here, we're going to talk about how to raise an I to an integer power. So, I to the 0, anything to the 0 power, if you remember your exponent rules, that was just the number 1. I to the first, well, that's just I. Now, I to the second, remember we've kind of been talking about that during this video, that was negative 1. Now, what about I cubed? Now, I cubed, all that is an I squared times an I, right? 2 i's times an I. Well, I squared, we know that's negative 1. And we know I to the first is just I. So I to the third is just negative 1I, or basically negative I, depending if you want to consider it that. And then I to the fourth would be 2I squareds, right? I squared times I squared, that can be I to the fourth, right? I squared is just negative 1. I squared is also just negative 1. So negative 1 times negative 1, well, that's just positive 1. Huh. That's the same as I to the 0. Interesting. I to the fifth, that would just be an I to the fourth times another I, right? So I to the fourth is 1 times another I. Well, that's just I. So I to the fifth is the same as I to the first. Interesting. Well, this is going to continue to happen, guys. When raising I to any integer power, basically the only 4 answers you can have are 1, I, negative 1, or negative I. That's it. That's all you can ever have. So ultimately, guys, you need to be able to simplify I to the 79th and give me which one of those 4 answers is possible. Now you're probably saying, Marsh, how are you going to do it? Well, here's what you're going to do basically. You're going to divide the exponent by 4 because there's 4 different choices that we can get. 1, I, negative 1, and negative I. If your remainders, now remember back years ago when you were dividing and you did 5 divided by 23 and you said, well, 5 goes into 23 4 times and that was 4 times 5 was 20. And you subtracted 3 and you couldn't divide 5 into 3 any longer and you said remainder 3. Do you remember doing that? Probably in elementary school. Well, that's what we're going to talk about today is the remainder. If your remainder is 0, then it's going to be a 1. If your remainder is 1, it's an I for your answer. If remainder is 2, you get a negative 1. And if remainder is 3, you get negative I as your final answer. So let's talk through I to the fifth. Well, I'm going to first divide my exponent, 5 here, by 4. Okay? I know I'm going to get a 1 with a remainder of 1. Right? 4 goes into 5 one time with 1 left over. So since my remainder is 1, my answer is I for I to the fifth. Let's try a bigger one. I to the 23rd. So how many times does 4 divide into 23? If you do it on your calculator, you are going to get a decimal. You're going to get something like 5.75, something like that. That's okay, but you know what? That 0.75, that's not the remainder. That's in decimal form. We want to know how much is left over. But that 5 tells us something. That's telling us that there is 5 4s in 23. So if I have 5 4s, that means I have 5 times 4, there's 20, right, in 23. So that would mean I have a 5 with a remainder of 3. Because 5 times 4 is 20, and I have 3 left over after I just subtract that 20. So since my remainder is 3, my answer for I to the 23rd is just negative I. That is my answer for I to the 23rd. Let's try negative 3I to the 56th. Well, that negative 3 is just going to stand out here until I figure out what this I to the 56th business is. So I got I to the 56, so let's divide 56 by 4. And that goes in perfectly, doesn't it? That's going to give us 14 with a remainder of zipperoni, so remainder of 0. So since my remainder is 0, I'm going to get a 1. So I to the 56, all that is just the number 1. So negative 3 times 1, negative simply 3. So we have added, we've simplified powers, we've multiplied. Now let's talk about dividing. So dividing, guys, takes a little bit. You can't have an I on the bottom of a fraction. It's kind of like a big no-no. Kind of like you can't have a square root on the bottom of the fraction. I know, a lot of rules in math. So how are you going to take care of that? Well, to divide complex numbers, you must multiply both the numerator and the denominator by what's known as the complex conjugate. Define this. Yes, I know, that's a really fancy name, but all it is basically changing the sign between the two terms in the denominator. That's all you need to do. Then you're going to distribute in both the numerator and denominator to multiply. You're going to simplify i's, so I squared equals -1 business. Combine some like terms, and then write it in the form of a plus bi. Let's try an example, because otherwise those directions don't make any sense. So I can't have 4 plus I on the bottom. It's bad. Doesn't work. Bad things. So what I'm going to do is multiply the top and the bottom by this guy, but it's not exactly that guy. It's going to be 4 minus I. So I'm just going to change the sign in between the two numbers or the two terms down there. Same thing on the top. Now let's multiply the top, the 3 by the 4 minus I. So basically that 3's got to distribute in, right? So I'm going to get 12 minus 3i over. Now let's multiply the denominators here. It is a FOIL. Now notice, guys, ultimately the inside terms are going to cancel off. Just wait. So 4 times 4 is 16. 4 times -I is a -4i. I times 4 is 4i. And I times -I is -I squared. Now notice, guys, -4i and positive 4i cancel out. That's what's so nice about that complex conjugate, is it cancels out the i's. Now you're probably saying, Marsh, there's still an I squared on the bottom. But I squared, remember, is just -1. So I can simplify the bottom even further. So I'm going to have 16. Well, I squared is just -1. So technically I have a -1, right? With me so far? So I got +1 on the bottom. So I got 12 minus 3i over 16 plus 1, which is 17. Now, to make it so it's in the form of a plus bi, I'm going to go 12 over 17 minus 3i over 17. Basically just taking this 17 and splitting it into its two separate pieces, so it's easier to see the two separate, the real and the imaginary piece. One more example. So I'm going to multiply. I have 2 minus I divided by the quantity of -3 plus 6i. So I'm going to multiply by -3 minus 6i, not plus 6i. Okay. There we go. Looks like I got a lot of foiling to do. So I got 2 times -3, that is -6. 2 times -6i is -12i. -I times -3 is a positive 3i. And -I times -6i is a positive 6i squared. All over. Let's multiply the bottom. -3 times -3, 9. Positive 18i minus 18i minus 36i squared. Yeah. Okay, I squared is just -1. So I'm going to get a -6 here, right? So if I combine my real pieces and then combine my i's, I'm going to get -12 minus 9i on the top. These guys cancel off. I squared is just -1. So this is going to become a positive 36. So 9 plus 36 is 45. Now, if I split it into its two pieces, I get -12 over 45 minus 9i over 45. Now, you're probably saying, Marsh, we're done. Hold up. We're actually not, because there's a number in 12 and 45. That's not a simplified fraction. I know, I'm sorry. But let's simplify it. I know a 4 can, or not a 4, a 3 can divide into both of those. So I'll get -4 over 15. And then a 9 can divide out of both of those. So I'll get a 1i over 5. So make sure you simplify for both pieces. Once you separate them, make sure you simplify the fractions that result. Okay? Careful of that. And that's the end of this video. See you later, Sabers.